you had a great night and a great week from the last time we met in the previous class for OSAD. So today we continue from where we left. But just before that, just give me a few minutes. I organize a few things here. So in the previous class, we looked at Introduction to Object-Oriented System Analysis and Design. We looked at the history of OOSAD. We looked at the principles of OOSAD. We discussed what a class is, what an object is, what a class is, what an object is, what is inheritance, what is polymorphism, what is a link, what is an association. We also discussed that there are three kinds of associations: unary, binary, and ternary. Yeah. The degree of associations: unary, binary, and ternary. And then we talked about cardinality ratios of association. Talked about one-to-one, one-to-many, and many-to-many. So that is what we did in the previous class. And also we talked about types of inheritance. We were also able to draw to illustrate the different kinds of inheritance: multi-level, multiple, hierarchical, hybrid, and single inheritance. So we looked at those things in detail, and we had a productive time. Now today, I also discussed with you. I also discussed with you the concept of generalization and specialization. We talked about the is-a relationship. The is-a relationship, or is a kind of relationship, and we said that we talk about the is-a or is a kind of relationship when we are generalizing classes and objects. So just a quick question before we start today's class: what is the difference between generalization and specialization? What is the difference between generalization and specialization? We say that there is a difference. So what is the difference? The difference between generalization and specialization. What is the difference between generalization and specialization? You can just type there. You can type there at the chat area. I have muted all of you so that because when all of you will speak, if all of you speak together, it will be a lot of noise from my end, and a lot of noise with my ears, into my earphones. So you can just type at the chat area. What was the difference between generalization and specialization? the difference between generalization and specialization? What's the difference? What is the difference between generalization and specialization? You can also include an example. If you can also include an example in your explanation to help you explain better. So Sylvia, generalization is a bottom-up approach. A higher entity must have some lower entities, while specialization is a top-bottom, top-down approach. A higher entity must not have any lower entity present. Generalization is a bottom-up approach. I think that's what you meant to say. It is a bottom-up approach, and generalization basically shows. It is used to show. Generalization is how classes are related to one another in a hierarchical relationship. How classes are related to one another in a hierarchical inheritance, or even any other kind of inheritance, as long as there are parent classes above it. So generalization shows how the classes below are related to the parent classes above, and how the parent classes above are related to the parent classes above. So generalization is a bottom-up approach that shows the relationship between classes from down up. in any kind of inheritance. Apart from, yeah, in any kind of inheritance. So generalization describes what kind of relationship and is a relationship. For instance, you can say that a cow is a mammal and a mammal is a animal. Yeah, so we did much of that in the previous class. Probably we can have such a thing like this. It's just to refresh your memory. We can have let me just use, instead of using a book, I think I can use Microsoft Word, which will make it appear better there, so that I can just share the screen. Right. So let me just draw this for you so that we can recap. You can use this to recap on your memory, to refresh your memory on what we are talking about. So if you have such thing as this, so you have a class, that class has members. So that class is a parent. Let me use landscape orientation so that you may have a better view. So we have a parent, then we have two child classes. Then these two child classes have a link that connects them. You have a link that connects them. So we have a link there. Let me share the screen so that you can see what I'm doing, so that you may not get bored there. So I think you can see it. I'm drawing this so that you can see the whole concept of generalization and specialization. So I'm drawing a link right now to show how they are related to one another, how these classes are child classes, or they are child classes of this. So we'll have that. We'll have that. Then we'll also have we copy this and paste it. We have that. So I'm using this as the board. Then we will have two child classes for each of these. So we'll have two child classes I want to copy this. Let me group them so that I can copy them together. Copy and paste. Let me paste it. That way. Copy and paste. Right, so we have this and we have that. So let me now name these classes. Add text. So in here, I'm going to call these animals. Let me increase the font for your benefit. Animals. Then I'm going to call these mammals, and I'm going to call these reptiles. And under mammals, I'm going to have cow and dog. Cows and dogs. Then under reptile, I'm going to have, what reptiles do we have? Snake. Which other reptiles do we have? I'm not a zoologist. The reptile I know alive is snakes. Lizard. A lizard is a reptile or an amphibian. Oh, lizard. Yes, lizard is a reptile. I had to Google that. Lizards. Okay. So that's what we have. So now, when you look at this, what kind of inheritance is this? By the way, what kind of inheritance is this? What kind of inheritance is that? The one that I've just drawn. What kind of inheritance is that? What kind of inheritance is that? What kind of inheritance is that? Andrew Nagila, Bogonko, Denver, Gideon. I want us to participate in class. Kipkoech, the true Kipkoech, Leland Paul, Linus, Riri, Lucio Anjiru, Manassas, Mutune. I want us to participate in class. Which type of inheritance is this that I've drawn here? What kind of inheritance is that? Yes, it is a hierarchical inheritance. It is a hierarchical inheritance. It is not a hybrid. A hybrid inheritance is a inheritance made up of two or more of the kinds of inheritance. So A hybrid can be a combination of single and multi-level, a combination of multi-level and hierarchical, a combination of hierarchical and multiple, a combination of any. But this one is a hierarchical inheritance, where a hierarchical inheritance is one where the classes, the relationship between classes downwards appear as a tree. Okay, they appear as a tree, they branch out. So you start from a parent, then you have two or more child classes, and in this case we have mammals and reptiles. Then these mammals and reptiles are also parents. They are parent classes of two or more child classes. So mammals is a parent class of cow and dog. Reptiles is a parent class of snake and lizard. Yeah. So that is a hierarchical inheritance. That is correct, Steve. Yeah. Then, so now I was trying to show generalization and specialization. So generalization is this way. This is how we show generalization. This is how we show generalization. Generalization describes a relationship between classes upwards in a top-up approach. In a top-up approach, this is what we call generalization. So if you can see that arrow that I've added there, let me add this so that arrow that I've just added there, that arrow I've added there shows generalization, the manner in which classes are related to one another upwards. In other words, generalization shows how child classes are related to parent classes above them, and how parent classes are related to their parent classes above them. So child belongs to a parent. That parent also is a child of another parent. So this is generalization. And you say that generalization shows always shows an is a kind of relationship, and is a kind of relationship. So let me just use a text box here so that you can see what I'm talking about. So an is a or is a kind of, an is a or an is a kind of relationship. So this is what we call generalization. Generalization describes an is a or an is a kind of relationship. Okay, an is a or an is a kind of relationship. That is what generalization is. Okay, that is what generalization is. It describes an is-a or an is a kind of relationship. An is-a or an is a kind of relationship. That is what generalization is. Let me increase the font here so that you can probably see it better. That's what generalization is. So this is called generalization. In other words, a cow is a mammal. A mammal is an animal. Or you can say a cow is a kind of a mammal, and a mammal is a kind of an animal. A dog is a kind of a mammal. A mammal is a kind of an animal. A snake is a reptile, and a reptile is an animal. A lizard is a reptile, and a reptile is an animal. So basically, a generalization shows how child classes are related to their parent classes upwards in a bottom-up approach, and it describes an is-a relationship or an is-a kind of relationship. Then, what is specialization? Specialization, as Sylvia said, it describes a bottom-up approach. So I'll just copy this, paste it here, I'll turn it So generalization specialization describes how parent classes are related to their child classes in a top-down approach. Top-down approach. So while this describes and is a kind of relationship, specialization shows a comprising, or what we call an aggregation relationship. Now let me write it here. Let me just write it here. It shows a comprising or comprise of relationship, what we call composition. What we call composition. That way. So this is specialization, the manner in which specialization describes how parents are related to their child classes, or branch out, or how parent classes form out child classes from them downwards. It's a top-down approach, and therefore it describes a comprise of relationship. So we can say an animal comprises of mammals and reptiles. Reptiles comprises of snakes and lizards. Yeah, yeah. So it also describes or a made of or a made of relationship. Made of relationship. Yeah. So you can say a car, we can have here, a car is made up of what? Of we can, let's change this. A car, so that we can illustrate the made of relationship. A car is made up of braking system, and lighting system. Braking system and lighting system. Braking system of a car is made up of brakes and brake pads, brake gear, and brake pad, brake gear, and brake pad, brake gear, and brake pad. Lighting system is made up of front lights and rear lights. So can you see how that works out? Yeah. I hope that you can still hear me. Yeah. So I hope that I can still be heard, and if coach, what distortion is happening? I'm trying to share back the screen. Can you see the screen that I've shared, or it's still not shared? I have had to reload the page so that it can correct the distortions, maybe. I don't know if it is now better, keep quiet. And also, are you able to see the screen I've shared? Let me stop sharing the screen. And let me share it back again. Are you able to see the screen that are you able to see the screen that I've shared? Or it's still loading? Keep quiet, or anybody, can you see the screen that I've shared? Or it's still loading? Can you see my webcam? Oh, you can see the word screen. Okay. All right. Can you see? Are you able to hear my voice and see my webcam? Are you able to see my video? Okay, then. All right. So let me continue then. So we can say a car is made of braking system and lighting system. Then braking system is made of a brake gear and brake pads. Then lighting system is made of front lights and rear lights. So also this is what we call specialization. It is a way of explaining how parent classes form their child classes and how those child classes become parents, or they become parent classes and they form also their child classes. So that is exactly what we are talking about. So it's a comprise of or a made of relationship, and this is called composition. Okay. Now that leads us now from this understanding, it now leads us to the next item for today. Let me share the screen. Let me share this, or let me see. Let me see. Let me see if I'm able to share the screen. Or let me just have that screen so that we can use it as I explained there. So now this takes us today into what we called aggregation or composition. So from last class, we stopped at one-to-one, one-to-many, and many-to-many. So now let's look at aggregation or composition, and I want us to focus on this these document that I've created here and I've shared to you that you can see. I want us to focus on this so that now we can look at aggregation and composition. Now, what is aggregation? Aggregation or composition is a relationship among classes by which a class can be made up of any combination of objects. Can be made up of any combination of objects or of other classes. It allows objects to be placed directly within the body of the classes of other classes. So aggregation is referred as a part of relationship or has a relationship. Part of a relationship or has a relationship. Okay. So Can you see here we have, so we are saying that aggregation describes a part of relationship. It describes a part of relationship, a part of relationship, or has a relationship. Has a relationship. So aggregation basically shows is directly related to generalization. Is directly related to generalization. And you normally use it when you are dealing with inanimate objects, used when describing inanimate objects, inanimate classes and objects. Yeah, aggregation, it describes a part of or has a relationship, and it is used directly, and it is used when we are describing inanimate objects, in other words, objects and classes that describe things that have no life. And they are directly related to generalization. For instance, you can say that a brake gear is a part of the braking system of a car, and a braking system is part of a car system, right? So it's also what we call generalization. Yeah. So we can also say here, we can, I hope that you can see as I'm typing here, it can also describe, generalization can also describe a part of relationship, or even a what has a relationship. Part of relationship. Part of relationship, that way. So we can say brake gear is part of braking system, and braking system is part of a car. Front lights is part of lighting system, and lighting system is part of a car. Rear lights is part of lighting system, and lighting system is part of a car. So aggregation is basically generalization for what? For inanimate objects. Okay. Yeah, because can you see hapa tukitumia is a, hakuna venye tunaweza sema braking gear is a kind of braking system. So that's true. We cannot say braking gear or brake gear is a kind of braking system. It's not a kind of, it's a part of. Yeah. This now is different from what? From animate objects. Like a cow is a kind of a mammal, and then a mammal is a kind of an animal. No, there's a difference. So when we are talking about these inanimate objects, that one thing comprises of an, or one thing is a part of another, it's a part of another, then we talk about part of relationship. So when you talk about part of, then you are talking about aggregation. Okay, so aggregation can only be, you cannot see what I'm typing. All right, just give me a few minutes. I reload this page. It seems I'm having a problem from my end. Seems I'm having a problem from my end. Let me just give me 1 minute. Okay. But can you see what I'm typing? Can you see something I've added? Hapo kwa generalization, I've typed part of. Hapo kwa generalization, I've added part of. Let me just allow me to. Okay, so I'm back. Let me share my webcam. And let me share the screen here. So this is what we are having. All right, there we are. Now I think now you can see it. So aggregation is when we are talking about inanimate objects, as I have just typed in the chat area. And it describes a part of relationship or has a relationship. So, or a part of relationship, not has a part of relationship. Part of relationship. Aggregation describes a part of relationship when you are talking about generalization for inanimate classes and objects. Generalization for inanimate classes and objects. So we can say a brake gear is a part of braking system, and the braking system is a part of car system. Okay. Then composition. So this is aggregation. Okay. Aggregation is like generalization for what? Is like generalization for inanimate classes that describe inanimate things, things that don't have life. Then composition is specialization for inanimate objects, or specialization is a composition is a specialization for classes that describe things that have no life. So you can say also here, now here I want you to see what I will type here. So we can also say that specialization describes has a relationship. Specialization describes has a relationship. So we can say car has a braking system and a lighting system. The braking system has a brake gear or comprises of a brake gear, and the braking system has a brake pad or comprises of also a brake pad. We can also say a lighting system has front lights and rear lights. All right. So that is what we call aggregation and aggregation or composition. Aggregation or composition. Aggregation basically describes generalization for classes that is generalization for classes that are inanimate in nature, and it describes a part of relationship. So you can say this child class is a part of this parent is a part of this parent. Then composition describes has a relationship, has a relationship, where you can say this parent has these two child classes. This child class has these two child classes. Okay. Yeah. So that is what we call aggregation or composition. So when you are asked what is aggregation or composition, you say aggregation is a relationship among classes, is a top-down relationship. It's just like generalization. It's a top-down relationship between classes that are inanimate in nature, and it describes a part of a relationship. And then you can say, you can draw something just as I've drawn there. You can draw and then you show, and then you can describe in words. A brake gear is a part of braking system. Braking system is a part of a car. Yeah. So aggregation is a bottom up relationship of classes. All right. That describes a part of relationship. Then composition is what? Is a top down relationship of classes that just like specialization, it shows has a relationship of inanimate classes. That is what we call aggregation and composition. Aggregation and composition. Now, there are two ways in which an object can be a part of another. Yeah, like it can exist in another. Okay. And that we are now describing what the part of and has a relationship. There are two ways in which an object or a child class can be part of another. One, physical containment, and two, conceptual containment. Physical containment and conceptual containment. Physical containment is where these elements that we are describing are physical in nature. So when we say a brake pad is a part of the braking system, that is what? Physical containment. Okay? Physical containment. In other words, the brake gear is contained in the braking system of a car, and it is physical in nature. A braking gear is physical, you can touch, you can see. So, and then there is conceptual containment. Conceptual containment is where we have a hierarchy of classes, but these classes are not physical in nature. You can only conceive them, you can only think about them. For instance, I want to change these ones, and I want you to look at this. So let's talk about education. Education. Courses. And courses will have ICT and engineering. Then we have business. Then under ICT and engineering, we'll have DIT and DEE. Then under business, we are going to have DHR and DPR, the Diploma in Human Relations, Diploma in Public Relations. Yeah, something like that. So, do you notice that these classes are not things you can touch, but you can conceive them? Yeah, they are not things you can touch, but you can conceive them. So, this is what we call conceptual containment. When the classes are inanimate in nature, but you cannot touch them. It's just something. It's an idea. It's a thought. You can't really touch. It's not a tangible thing, but you can conceive it. You can conceptualize it. Rather, you can conceptualize. You can think about it. So that is what that is what I'm talking about. Their classes can be, when we are talking about aggregation and composition, because now we are talking about inanimate objects, classes can be contained in other classes in either physically or conceptually. So that's where we have physical containment and conceptual containment. So physical containment is where child classes are contained in their parent classes physically, and these parent classes are also contained in their parent classes physically. So like a braking gear is contained in the braking system of a car. The braking system of a car is contained in the car system. All right, but conceptual containment is where there is no physical, the objects are not physical in nature, they are only conceptual. You can only think about them. Like courses, DIT is contained in ICT and engineering, and ICT engineering is contained in courses. So basically, that is what we are talking about: aggregation and composition. That is basically what we are talking about. And so we want to finish chapter 2 by talking about the benefits of object model. Why are we using classes and objects? Why should we use classes and objects? And this is going to help us to appreciate the rest of the content of the unit better. Why should we use object model to design or to develop systems? Number one, it is faster. It helps us to design systems faster. Also, the object model is easy to maintain. Why are we saying it is easy to maintain? Because it is very, very easy. It is very, very easy to, let me go back to this, it is very easy to restructure your classes. So you can add. So ukitaka kuongeza hapo utaongeza, like ICT and engineering, business, you can also add another class by just extending this line. Okay, you can just extend this line and you can add another. You can add another class. If you want to have another class, you can still add it, and then you extend this relationship. Yeah, you extend this relationship, yeah, something like that. So it is easy to maintain. You can add features, you can remove features as you deem fit. Then also the other benefit is that it enables us to reuse objects, designs, and functions. So reusing of objects, and that is what we call inheritance in the previous class, inheritance, where we do not have to rewrite the functionalities of code or rewrite the functionalities of a particular group of code. We only inherit the properties of that object. So for instance, like DIT has the properties of ICT and engineering. Like DIT kama courses zote za ICT and engineering, they start with the code IE. Let's say the code IE. That means kila student atakuwa na hiyo code kwa DIT, kila student atakuwa na hiyo code kwa DE. So that meaning that the properties of this class have been inherited by DIT and DEE. Yeah. So there is that concept of inheritance where we are able to reuse. We're able to reuse the properties of objects or reuse the properties of classes. And basically, also the other very, very important is that object model, they help to integrate different parts of a system to build even more complex systems. Why so? Because you are able to understand that system better using an object model. So you are able to increase these kinds of classes. You are able to increase classes. You can increase more classes as you deem fit. You can keep increasing these classes as you deem fit. You can keep extending these classes as you deem fit, and you can build a more complex system. Yeah. So object model enables us to build more complex systems. They're also easy to maintain. Object models are also easy to draw, and they are also fun to draw, as you will see in the other diagrams that we're going to be drawing, in the other UML diagrams that you're going to be drawing. They are easy to draw, they are fun to draw, and the systems themselves, you can develop those systems faster. Why? Because the models themselves, the design themselves, they are easy to understand. So you are able to interpret what you've designed to code very fast. All right. So that is so that brings us to the end of chapter 2, which is object model. Now, let us look at or the end of chapter 3 rather, because chapter 2 had principles of OOP. Let us look at the phases in object-oriented software development. The phases in object-oriented software development. The phases in object-oriented software development. So let me share this screen. I had a disconnect from my end, so I've had to reload. Let me share this screen so that we can go through it together. The phases, I was talking about the phases or the stages of developing an object-oriented system. What are the stages of developing an object-oriented system? Let me share this screen. Let me zoom it for you. You can see it better that way. So there you go. So let's discuss the phases in object-oriented software development. What are the different stages in object-oriented software development? Now, there are three main stages in object-oriented development or developing a system using the object-oriented approach. First of all, there is analysis, then there is design, and there is implementation. Those are the three. Now, of course, in other programming paradigms, which you have already learned, like structured programming, you normally talk about like 5 different stages, where you can have 5 different stages. Like you first identify the needs or system requirements, functional and non-functional requirements. Then you do system design, system analysis, coding, testing and debugging, implementation and maintenance. But in object-oriented approach, that is why you even say that object-oriented approach is what? It is simple. We only have to do 3 things. We only have to analyze the system, design it, and implement it. Now, let's look at object-oriented analysis. Object-oriented analysis. So we have analysis, design, and implementation. Those are the 3 stages of developing a system using object-oriented approach, or what we call phases in object-oriented design, or phases in object-oriented development. So what is object-oriented analysis? Object-oriented analysis, you identify the problem, that is what should the system do, and also the user requirements. All right, that is what analysis is about. Identify the problem. In other words, what should the system do? Then identify user requirements. What does the user need so that they can receive the service from that system? Then you build a simple model from the understanding of the problem and the user requirements. So let us have an example like an M-Pesa system. An M-Pesa system, the problem that was formulated is mobile banking or mobile money transfer or mobile money transactions. So that was a problem. And then the user requirements were things like the user will require a module for withdrawing money. The user will require a module for sending money. The user will require a module for buying airtime. The user will require a module for depositing in M-Shwari, to save in M-Shwari. The user will require a module for all those things. So you need the different modules that the user can use so that this system can be of benefit to them. So basically you identify the things that the user requires in the system. Yeah, the things that the user will require in the system after formulating the problem. Then now you can just draw a simple model, anything, a very sketchy diagram. So object-oriented analysis is where you do a sketchy diagram from the problem that you formulated and the user requirements you think the user will need. Now, user requirements are informed from the user side. User requirements are informed from the user side. It is the user that says what they require. So if you are the developer and the company that has hired you, the clients, you're not getting the shared screen. Does anybody get the shared screen? Can you get it now? Are you? Yeah, the screen is there, so keep quiet, look from your end. Seems the rest can see the screen. So what we are saying is that when you are developing a system for a company, that company has clients. Those clients are require a system that does particular things. So it is the users that say what they need. Now you as the developer, you are integrating those features into the system. So basically in analysis is to do just an analysis of an overall analysis of the system, where you'd identify the problem, what is the problem being addressed by the system. So in this case, we are talking about an M-Pesa. Let us even assume that we've not even given it a name. It's not called an M-Pesa. It is normally given a name at the implementation level. Okay, so a name that the users will like because of marketing, of course. But then, of course, now for us, the programmer work is to identify the problem. What is the problem? The problem is mobile money transfer or mobile money transactions. That is a problem. So we have heard from the users or from our clients that they need a system that can help them to deposit money. Instead of depositing in their bank account, they can deposit it in a smaller framework like a phone account using their SIM card Safaricom account. Users also require to send money to each other instead of using bank transactions, because banks are normally far from each other. You'll have to go and withdraw, and such things. And also withdrawal charges are high. They also require a way in which they can send money to each other. They also require a way in which you can deposit money that is it's liquid in cash. You can have it in your phone. The users also require a way in which you can buy airtime. If you have money in your account, Safaricom account, you can buy airtime when you deem fit. So now those requirements are informed by who? The user. So you, the programmer or the developer, you do an overall analysis of the system. The problem being addressed is mobile money transactions. User requirements: withdraw money, deposit money, send money, buy airtime, do loans like M-Shwari and such things, give loans. What are some of the other user requirements? They would require something for buying airtime. Yeah, so those are the user requirements. So when you are doing that sketch, then you draw a sketch of all that. When you do that, you are doing what we call object-oriented analysis. You are doing analysis. You identify the problem, and then you identify the requirements, the user requirements that will address that problem. Then you go to design. So in design, there are two kinds of design. There is system design and object design. Now, designing basically designing the whole approach. Before we look at system design and overall design, designing is basically now developing models. And in designing is where now you draw diagrams, class diagrams, object diagrams, sequence diagrams, collaboration diagrams, DFD diagrams, all those diagrams that you are going to study in this unit. So design is where now you draw a diagram that represents the system, okay, and how the different classes and objects in the system relate to one another and how they function, and also how they pass to each other messages. So in design is where you do a detailed sketch or a detailed drawing of the different parts of the system. You represent using drawings, and we are going to show how we are going to design. Yeah, we are going to design using the drawings. Tutakuwa tunachora. Of course tumeanza kuchora, but there is a lot to draw which we are going to do. So there are two types of design. There is system design and object design. System design is where you draw the complete architecture of the system. Unachora hiyo system yote venye inahitajika. For instance, like the way we are drawn the different hierarchical inheritance. This inherits to this. This branches out to this. This branches out to this. Venye tulikuwa tumechora. So you drew an overall design of the system. That is called system design. An overall design of the system. Now, system design is not detailed in nature. System design is not detailed in nature. For instance, if we have said that this mobile financial transaction system is going to help users to transact money using their mobile phone, then we are going to draw just the overall modules that are needed, So based from the user requirements, we are going to draw from the mobile money transaction system, then you're going to branch out into classes like withdraw money, deposit money, send money, buy airtime, and loans. Okay, so it is an overall what? It is an overall sketch. It is called system design. Then when you go to object design, this is where now you go into details. Yeah. Now, by going into detail, you will develop new class, you will draw new classes, you'll have to create new classes from scratch, you'll have to branch out classes from existing classes, you will have to show the properties that are inherited from the main classes. So while system design is an overall drawing, object design is a detailed drawing. So ukiangalia kama M-Pesa system, the M-Pesa system iko na tu the general things: withdraw, deposit, send money, buy airtime. But if you go into details, you'll find that all of those classes, you can still branch them out into new child classes. Like withdraw money, you will have an object for entering amount, entering ID number. Sindio ama entering, yeah, something like that, or something like that. And then deposit money, you're going to have some details in it. Ndani yake iko na details mingi. So every child class has a lot of implementation details. So those implementation details, you keep drawing them. So you kind of deduce new classes from the already existing classes so that you can keep branching out. Everything. And when you are done with another child, you keep branching out. Now that is called decomposition. What we call object design is called system decomposition. System decomposition. And what that is, system decomposition is where you break down parts of a system until you cannot break them down any further. You go into details, you keep drawing until you cannot draw any further. In other words, there is nothing else to represent. Okay, there is nothing else to represent. Na tutaangalia hivyo tukianza kuchora hizi diagrams, tukianza kuchora class diagrams, state transition diagrams, sequence diagrams, collaboration diagrams, interaction diagrams, activity diagrams, robustness diagrams, those kinds of diagrams. Hizo zote zenye tutachora, tukianza kuzichora, we'll be doing system decomposition. Tutakuwa tunaanza na the major elements of a system. Na hiyo inaitwa nini? Hiyo inaitwa system design. Ukichora to the major elements of a system, then you keep breaking them down further until you cannot break them down anymore. Then that one is called object design, where now you go into detail, you break classes into new classes. Those new classes, you break them into new classes until there is nothing else to draw. So we have those two. Let me back up here. So we have analysis. Analysis is where you identify the problem that exists and you do as an overall sketch of how that system can look like. Just an overall sketch. Okay, an overall sketch. Then object design, system, when you come to design, is where now you begin to draw specific diagrams. to show how the different classes and the different objects relate to one another. So there we have system design and object design. System design is where you do the first condensing, yeah. So system design is where you do simple condensing, simple condensing of the system. Simple condensing of the system. So kama ni mobile money transaction system, unaonyesha the first class yenye, the first class itakuwa the general system, mobile money transaction system, then you branch it out into main classes. So una form main classes, just main classes zenye hazina detail, vitu zenye hazina detail. That is system design. You have things that don't have their details, just modules of the system that are going to be, from the overall look, they are going to be seen, just modules without the implementation details. Okay. And then now when you go to object design, now that is where you go to each module and you decompose it further. Each module unaangalia kama ni withdraw money, ndani yake itakuwa na elements gani? Itakuwa na element ya enter amount, enter ID number, validate, press OK. Press OK is validate. It should also give an error message if it does not, your amount does not reach, or your ID number is not correct, or you are not there at the M-Pesa station. It will give a message to the M-Pesa person there, something like that. Okay, you go now to deposit money, una break it down further. Your deposit money itakuwa inawakaje? You break it down further. So you as the developer, when you are doing object design, you kind of decompose every class further, or every module further, until it cannot be decomposed anymore. And we are going to show that as we draw. Yeah, the way we are going to be decomposing every we are going to be decomposing every module of a system to the least point, to the until you cannot break it down any further. Yeah, depending on the question that you are given. Then now there is implementation. Implementation is where you code. Implementation is where you code the system. And coding is now where now object-oriented programming 1 comes in. All right. So implementation is where you code. And of course, for you to code, you need a what? You need a software for coding. Yeah, you need a software for coding. And so for our case in object-oriented programming 1, we are going to use what? Code blocks. So that is where you are going now to code some of our systems. And there is also testing. Okay, so testing is just checking whether the system is working as it is required. You run the system, you see what output it gives. You also run the system, you see whether the output matches to what you expected. You also see whether there are conflicts, and you correct those conflicts before you now launch the system or you put it into use. Okay, so basically that is what we have. That is what we have in object-oriented, the phases in object-oriented development, the phases in object-oriented development. Now, we had looked at these principles of OOP, classes, objects, so we don't have to go through it again. Maybe you can ask a question if you have a question. If you have any question, you can ask. Before now, we look at analysis, design, now in further detail. Any question? Any question? Any question? Any question from what we've just shared? Okay, then. So let us now then go to, we have looked at the phases in object-oriented development: analysis, design, and implementation. So now we now look at analysis ikiwa peke yake, design ikiwa peke yake. So in detail. So let me just give me a few minutes here. So let's go to object-oriented analysis. So in your course outline, you will find that this is chapter 4. Chapter 4. This is chapter 4. Let's have a, before we go to that, let's have a 5-minute break. Just a 5-minute break, and then we get back, okay? A 5-minute break, then we get back. Just a 5-minute break, then we get back. So you can take a break of 5 minutes, then we get back now to class so that we can now do more. All right, let's do the last part of this class. Object-oriented analysis and object-oriented design. So in object-oriented analysis, we've said before that object-oriented analysis is the way in which we identify the problem that is being addressed by the system and also the user requirements, and draw an overall sketch that comprises of the major classes or the major modules of that system, without going into the details. Now, there are three analysis techniques. There are three analysis techniques that we can use when we are doing object-oriented analysis. There are three analysis techniques. Now, there is what we call object modeling, dynamic modeling, and functional modeling. Object modeling, dynamic modeling, and function modeling. Now let's look at object modeling. In object modeling, this is basically what you do. You identify the objects and group them into classes. You identify the different kind of objects and you group them into classes. You identify the relationships among classes, and this is what we call one-to-one, one-to-many, and many-to-many. So you identify those relationships that exist. Then you create a user object model diagram. In other words, how does the user interact with the different objects that are in the system? Then determine what data is being involved. So attributes are data, as we had said in the other previous class last week, that an attribute is a data set like length, width, height, amount in shillings. Vituka hizo attributes is data. Then also you define the operations that should be involved, like area is an operation, volume is an operation. An operation is basically a function that uses data, or a computation that uses data to provide what? An output, that uses data to provide an output. So when you are doing object modeling, when you are doing object modeling, you basically do that. You identify the objects that are there, the classes that are there, you group the objects into their classes, show the relationships, one-to-one, one-to-many, and many-to-many, and also show the data, the attributes that are there, and show the operations, or what you call the functions, the methods that are in those classes. Now, the thing about object modeling is that this particular part, all these object modeling, dynamic, functional, we are going to look at them in drawing tukiendelea. Okay, so I'm just doing an overview. Kutakuwa na place tutaanza kuchora drawings for each of these. Then dynamic modeling, after you have determined the objects and the classes and the attributes and the functions, let me just do for you a summary here. So object modeling, so these are the activities. Just a summary of these things. Identify objects and classes, identify the relationships between objects and classes. And so here you're talking about one-to-one, one-to-many, one-to-many, and many-to-many. Then after that, you identify the attributes. Identify the attributes or data that is associated with those classes. Then you identify the operations. So those are the activities that are done in object modeling. Classes, objects, relationships, attributes, and operations. Then when you go to dynamic modeling, so after you've already done that, now dynamic modeling is where you determine the behavior of the different parts of that system, like the classes and objects you've identified, the behavior of the different parts of that system with respect to time. How do different parts of that system, how do different classes and objects in that system behave at every given time? And also, how do they behave when they are provided, when there are external activities going on, like when the user is providing input, such things like that. So dynamic modeling, this we are dealing with behavioral concepts of objects and classes based on time. So let me just do a summary here for you. So in dynamic modeling, what does that do? Dynamic modeling, it identifies how objects behave at given times when certain things happen. Yeah, that is what dynamic modeling it has everything to do with the behavior of objects at every given instance when some certain things happen. For instance, an object like send money, in the M-Pesa module, in the M-Pesa system. So send money is just one of the modules or one of the classes. So the object send money is going to, there's going to be things that are going to be happening. Like for instance, if I enter the right code, the right amount, and the amount is less or equal to what I have. Meaning, if I want to send money, I want to send 1,000, and I have 2,000. Meaning, I am able to send money. So if I input 1,000 and I input the correct PIN number, this send money module should send a message to the account. Yeah, it should send a message to my account, to my money account. So it should send a message to the account telling it to send money to that particular number that I have provided. Yeah. So there is a way in which that object, which is the send money object, behaves. Okay. When particular things happen, or for instance, when I put the wrong number, the wrong ID, the wrong PIN number, or the amount is not enough, then it will have to give me an error message, not an error, but a failed message, that the transaction could not be completed because you have less money in your account, and then it closes down. Also, whether or not the transaction was successful, when the transaction finishes, whether successfully or not, whether it finishes with a failed message or it finishes by telling me successful, you have sent money to this number 07 something, always what happens is that it closes the M-Pesa module. That's right. So basically, that is a behavior, how an object behaves when certain things happen. So for instance, like when you finish using the send money module, when you finish, whether you send successfully or you do not, when you finish it, you'll have to close the module and return you back to the main M-Pesa menu. It will return you back to the main M-Pesa menu. So that is a behavior, how an object behaves based on some certain things that happen. So dynamic modeling deals with behavior of objects based on what certain activities. Okay, what objects do, like an object can close, an object can open, an object can expand, an object can minimize so that another object can be in the forefront. Yeah, another, like when you're installing a software, you will find that when you're installing a software, that particular wizard will come to the forefront. For some softwares, you can't minimize it, just it stays there on the screen until it finishes installing. So that is a behavior of an object. Yeah, what an object does during its lifetime. Are we together? What an object does during its lifetime. Yeah. When you call, let's just talk about a calling system. When the calling, yeah, the normal call, when you're calling somebody via phone. When you call somebody, you dial their number, the caller, whatever, the caller interface appears, right? Then when you exit, the caller interface disappears, right? So that object, that caller interface is an object by itself. Yeah. There's a way it behaves based on some certain activity. So when you close, it disappears. When you open, it appears. When you press the home menu of your phone when you are on a call, what will happen? The call will be ongoing, but it will happen in the background. And when you actually scroll it, when you scroll from the top, you'll actually find it that it's actually ongoing. Yeah, it's that the call is ongoing. So, but it's in the background. So, how an object behaves based on certain things or based on certain activities is now that all that is described in what we call dynamic modeling. How objects behave, the behavior of objects based on some certain things when certain things happen. Okay. So here in in dynamic modeling, we are going to look at some things. In dynamic modeling, we are going to look at some things. We are going to look at a very important concept. I want you to follow. You have the notes, but I want you to follow as I teach. The most important thing that we are looking at in dynamic modeling is the state of an object. What I've just highlighted there, the state of an object, the state of an object. The state of an object is the behavior of an object at a given instance. Okay. For instance, if you are calling somebody, the caller interface, we can say it is active. Then when you exit, the caller interface is inactive, right? Yeah. So such things, the state of an object is how an object behaves per given time based on some activities that are happening with it. Okay. So here we are also going to look at in dynamic modeling, we are going to look at state transition diagrams and state chart diagrams. So we are going to represent, let me just summarize for you. In dynamic modeling, dynamic models are represented using state transition diagrams and state chart diagrams. Basically, state transition diagrams and state chart diagrams, they show the state of an object at every given instance or at a given time during its lifetime or during when it is used. When you say the lifetime of an object, the lifetime of an object is basically when it is in use. That is what the lifetime of an object is, when that object is in use, the lifetime of an object. So we represent dynamic modeling. We do dynamic modeling by drawing these two kinds of diagrams: state transition diagram, state chart diagram. A diagram is basically a model. Okay. And we are going to look at those diagrams, but not yet. So we are still going through these things so that we can familiarize ourselves before we get into the diagrams. Okay. Then when you get to functional modeling is always it deals with the processes. It deals with the processes that are performed within an object. Now, dynamic models deal with the time or the behavior of an object based on given activities in a given time, the behavior of an object. Functional modeling or functional models, they deal with the processes that are taking place. So processes are basically things like messages that are being passed, inputs and outputs, how data is being processed within that object at a given time, and such things. That's why we are talking about the inputs and outputs that are coming into the object. For instance, Kama send money itself, it's an object, all right? Send money. But for you to send money, you have to provide some input, like amount of money and M-Pesa ID number. So whatever inputs that come from an object and whatever outputs that come from an object, they are all described using functional modeling. And in functional modeling, we are going to be looking at such diagrams as the following. So functional modeling, dynamic modeling deals with the states of an object. Functional modeling deals with the processes, and processes involve inputs, outputs, and data processing. So functional modeling is going to be represented by diagrams such as there are different diagrams, sequence diagrams, data flow diagrams, activity diagrams, interaction diagrams, right? And others. I think there are two more, but we're going to look at them. Of course, as we begin drawing, we're going to see each of them specifically as we draw. So dynamic modeling deals with the states of an object, and here we will be representing the state of an object or the behavior of an object using state transition and state chart diagrams. Then functional modeling deals with the processes of an object, and here we have the inputs, outputs, and how data is being processed in that object by the system in that object. And here we are going to represent using sequence diagrams, data flow diagrams, and activity diagrams, and interaction diagrams, and so forth. So I want you to get the differences. The reason I'm summarizing is because the notes are also detailed, okay? So I'm summarizing here so that you can know what we are talking about, okay? Yeah. Basically, what you can see I'm passing in the notes is just what is the difference between structured programming approach, and object-oriented approach, which you can read on your own. Okay, it's just a comparison, but we had already done the benefits of object model. So from benefits, you can actually talk about the differences. Yeah. So that's why I'm passing it, so that you can always go to the main things. So now let's now look at dynamic modeling. This is well, this will involve a lot of drawing. This will involve some drawing. In your course outline, dynamic modeling is chapter. Dynamic modeling is chapter 5. So now from now henceforth, we are going to be doing a lot of drawing. You're going to be doing a lot of drawing. So I also want to download a software which is going to help me draw faster than Microsoft Word, which I can use as a whiteboard software, which I can use. So from now on, we are going now to look at dynamic modeling and now draw diagrams. So we look at a system, we draw its diagram. We go to functional modeling, we look at a system, we draw its sequence diagram, we draw its data flow diagram, we draw its activity diagram, henceforth. So, but basically the things I want you to remember now for this class is these things. Dynamic, in object-oriented analysis, we have three kinds of models: object models, dynamic models, and functional models. Object models, we are dealing with objects and classes, the relationships between those objects and classes, the attributes or the data that is being the data that object has, and also the operations that the object performs, like sum, multiplication, product, division, things like that, or computation of school fees, things like that, things that have to do with computation. Then dynamic models have to do with states or the behavior of an object at a given time. And we are going to be using state transition diagrams and state chart diagrams. Then functional models, which is the third kind of models in object-oriented analysis. Functional models deals with what? The processes of an object. And processes, we are talking about the inputs, the outputs, and how data is being processed within the object. And to represent that, we represent using sequence diagrams, data flow diagrams, activity diagrams, and interaction diagrams. So from the next class now going forward, we are now going to be drawing a lot of diagrams. We have like 11 kind of diagrams that we are going to draw up to the end of the unit. So from next class, we are going to be looking at every kind of diagram, on its own. And then we kind of have a system. So I'll be giving a sample question like something, this system does this and this and this. I explain as a narrative, and then I say explain or represent, design this system using an object, using a sequence diagram, or using a class diagram, or using an object diagram, something like that. So from the next class, you are going to be drawing. So that is what we have. So instead of getting into drawing right now, I want you to process these things that we have talked about, so that now when we get into diagrams, it's going to be easy, and it's going to be fast. It's going to be fast. So that is what we have. I wish that we stop at that, so that from the next class now we can go into the details of drawing and such things. Any question? Any question? Yes, these things are applied in system analysis. It will be part of your career when you are a programmer. It will be part of your career, analyzing systems and drawing those systems, because analysis and design of systems always comes before programming. So if you'll be a developer, as part of your career, you will have to learn how to draw systems, how to represent systems using models. And it is now from these models that you can explain to people, probably the board of the corporation or the organization, how that system is intended to work. And it is also from those models help you to understand if your system, finally, after developing it, after coding it, if your system works the way you had modeled it. Okay, so those models enable you to know whether your final system looks like the initial system that you conceptualized. So it's like a real house, like a house. You first draw, you get the architectural plan of the house, and then after building, you go checking if that house has everything that that is shown in the architectural plan. Does it have this? Does it have that? So models are very important in programming. When you be a software developer, models are very important. You're going to be drawing models for systems. You're going to be drawing models for systems. And when you draw models for systems, they have an importance. Models help you to understand your system, the system that you are coding. They help you to understand the system better because kuna drawing. So you can compare what you are coding to what you have drawn to see whether, and so this drawing of yours, the model is like the architectural plan. It is the one that helps you to know what to implement in the coding. Okay, so it is very, very important. Models are very important, especially if you will be a developer. Models are very important. Also, as we have said, models are important when you are explaining to amateur people that don't have a lot of IT or programming knowledge, like the users, all right, the users of the system, how different parts of the system work. Okay, so you can explain to the users, instead of using code, you use the models to show users, hii ukifinya hii itakuwa inafanya hivi, hii ukiopen hii itakuwa ina send message to this one. So it is also, they are very important when you're interacting with system users to show them how it works. Okay, yeah, and also for comparison at the end of the development, you can compare whether what you have developed matches with what you had modeled, because he modeled your guide. So you see, when you come to system testing and debugging, you want to check whether the system meets its functional requirements. You compare it with the what? With the models. Okay, so always when we are drawing these models, I want you to see them like an architectural plan of a house and see how important an architectural plan of a house is. In fact, there is no house, few houses, all houses, 99% of houses are built from an architectural plan. You can't build without a drawing, an initial drawing. Okay, so see them like an architectural plan, and the code is the main house. Okay, the real house, the stone and cement, that is the code, but your architectural plan is the model. Okay, so if you can think about the importance of a model, of an architectural plan, then you know the importance of a model, of a system model. So those are the applications in real life. They are very, very important when you be a programmer or a software developer of an organization. We'll be drawing these models day to day, every day, every time as you draw project, as you build projects for the organization, you are going to be working with these models every time. Okay, yeah. Any other question? Any other question? So remember that models are plans. A model is a plan. So when we begin to draw these diagrams, it is like a plan for a main system. They help you to conceptualize the system better, to understand the system better. So that whether you or another person is the developer, the one who is coding, they can understand the system better and they can implement it. They can code the different parts of the system using that model. So a model is like an architectural plan. All right. So we can stop at that, so that now from next class, we can now begin drawing the different models. Are we together? The object models, the dynamic models, and the functional models. Okay. All right then. So that is it for today. Have a good day.